Hello guys, thank you for joining. Today we're going to be talking about the Leetcode question 122, best time to buy and sell stock 2. So this is a really interesting problem, deals with arrays. Let's go straight into the input or problem statement. So you are given an array prices where prices at the index I is the price of a given stock on the ith day. Find the maximum profit you can achieve. You may complete as many transactions as you like. Buy one and sell one share of the stock multiple times. You may not engage in multiple transactions simultaneously. You must sell the stock before you buy it again. So this is basically a modification of the best time to buy and sell stock 1. That's an easier problem. With this problem, it's actually just how one of the easy ways to kind of solve this problem is by drawing it out. So let's draw out 2 of the examples. So one of them, 7, 1, 5, 3, 6, 4. And the second one, let's do 1, 2, 3, 4, 5. So if we were actually to look at this as a price chart, to say 7 at the highest, the lowest, and then the bottom one is the index, right? 5, 6. So our first point is going to be at 7. Then we're going to be at 1. Then we're going to be at around 5. 3 is going to be around 3 right here. 4 is going to be around 6, which is slightly above 5. And then the last one, 4, is going to be around here. So if we actually look at it as a graph, it's going to look like this. So basically, our job is to capture all the multiple ways you can gain money. So if you can almost think about it, we're looking for peaks and valleys. So the peaks being the times to buy right here and here. And the peaks being up here, the highest prices, and the valleys being the prices to buy right here and here. So how would we intuitively find that out? Just by looking at this array or this graph? Well, we would see that it might make best sense to just buy and sell. So buy when something's down, and then if something is greater than it, then sell. So in this case, 1 to 5, we'd have a profit of 4. Then if we bought at 3 to 6, we would also have a profit of 3. So we can make a profit total of 7. Now if we go to the bottom one right here, the highest one is 5, 0. We would have a constant climb, right? So in this case, it would just make sense to buy on the lowest part right here and then sell at the highest point right here. So that would be 5 minus 1, which equals 4. And then if some graph were to go down, you would want to not buy or sell, so it would have a profit of 0. So how do we actually categorize that in code? So one approach would just be to iterate through an array and then also check its next value. So let's say, for example, like you start right here and you notice that the next value is less than it, then you just iterate again, and then you would iterate till you found a way where you're buying at a valley and selling at a peak. So in this case, if you were at index number 1, you could also check index I plus 1, or 1 plus 1 equals 2, and see that there's a profit to be made. So you could sell at both. And then just track that to external variable, let's call, for example, max profit. So you just repeat that process. So if you're able to sell profit here, then at the end of that, you just go to the next variable and then see if it's possible to make a profit. It is. So this would be I. This would be I plus 1. So then you'd add that to max profit. And also, again, you would move here, but then there's no other price to check that. So there'd be no way to buy or sell in this last element. So how you could solve this in code is by the first approach number 1, keeping track of 2 variables, one called valley, one called peak. It would start at both the same point. So R0, R0, you would do some type of while loop on an index I, and you would be looking for specific conditions. So the first condition in a general while loop that is less than the length of the prices array, you would be looking for a price until you found a price at the ith index that was greater than or equal to prices I plus 1. And that would be your valley. So if we wrote that in code, it would be while I is less than prices dot length minus 1 and prices I are greater than I plus 1. So why do we want to have that loop? Well, we want to keep adding by 1 till we find a price at prices I that is less than prices I plus 1. And then we would assign that to our valley. And then the reverse portion too, we would have another while loop. I know there's not enough space here, but we would have another while loop that does the same check while price I is less than prices dot length minus 1 and prices I is less than or equal to prices dot I plus 1. While that's the case, we want to also increase that until we find a variable that is greater than your valley. So the peak will be greater than your valley. And then we just add that to the max profit, that difference. So max profit plus equals peak minus valley. Then eventually we just return the max profit. So it's going to be a little more clear in code, but an easier way to do this would just to do it in one pass. So how would that look like? So we would still have the same, and this is approach 2, by the way. We would have some type of int called max profit that we keep a tally of. We would just iterate normally through the prices array, but we'd start at 1. So why 1? It's because we want to check the current index and also the index past it. And this is where it gets really interesting, because if you think about it, you could just literally keep track of every peak and valley as you iterate and just add it to it. So if you think about it logically, if something goes down, it's not going to get tracked, but if it keeps on going up, you want to keep track of every upward motion. So this is what's getting done in approach number 2. So, sorry it's getting a little sloppy, but it'll be a little bit more clear in code. All you have to know is if the prices at I is greater than the prices of the previous element, then we want to add that to max profit. So it's similar to approach number 1, but it's just a little bit more cleaner. So prices I minus prices I minus 1. And eventually we return the max profit. Okay, so let's code this out in Java and Python. for Java, we're gonna code out both, and in Python, we're just gonna code out approach number 2. So in this case, we'll go for the first one first. We'd have a max profit equals, max profit equals 0. We would have our valley portion at the first iteration and the peak one at here. We start at int I. We would basically have one giant for loop that checks that we are within the bounds of the array, and then we'll have 2. So actually, I can just copy this right here. We'll have 2 iterations that basically track a peak and a valley. So first the valley, then the peak. And then we want to keep on adding to I until we find a price that is less than its neighbor or next neighbor. So if that's not the case, it'll keep on adding by I. So then valley equals prices. So yeah, valley equals prices I. And actually, if we just want to make it cleaner, I don't even need these parentheses. I can just have it be right here. And then the same, except now we do the opposite. We want the actual prices to keep on iterating if it's less than less or equal to prices.i plus 1, because we want the ith index to be greater than its previous one. That will be our peak. Then we add that to the max profit. And then at the end of that, we return that max profit. Okay, and we can just simplify this too. So the simplified one is we keep the max profit, but then we just change it into a simple for loop. So that for loop, remember we kind of like reverse it in a certain way. Instead of checking the next future neighbor, we check the past neighbor. So I is less than prices.ling if prices I is greater than prices I minus 1. Then we just add that to max profit. And that's just a simpler way to do it, one pass. Oh, I forgot to change that to 1. Oh, and I did a simple mistake here. Yeah, so just did a simple mistake, clean that up. Now it shall pass. That's how you do it in Java. So let's do approach 2 in Python. In Python, again, we're just going to use the simple iteration. So you think about it like on a graph, we're just going to track all the upward trajectory. So we just want to do our base case. So if the length of prices equals 1, then just return 0 because there's no possible way to make any profit. We're going to create an array called max profit. And actually just call 0 here, to be honest. So for I in range 1 to the length of prices, if, and we actually don't even have to call that prices I is greater than prices I minus 1, then we just do max profits prices I minus prices I minus 1, and then we just return that max profit. So yeah, it's just a simple way to do this in Python. And as we can see, it's just a nice, simple way. So when you actually think about this problem, it's actually kind of intuitive when you look at the graph. So if we actually look at the solution here, this is what we're talking about, the peaks and valleys. So check out these these visualizations if you can. But yeah, this is a great way to kind of do it in a single pass. So thank you guys. See you guys in the next video, and cheers.